Hello, my dear warriors. I hope you can see me and hear me loud and clear. And I hope I'm audible as well. Welcome aboard, welcome aboard, welcome aboard. I'm so sorry for this short delay because I was just ending my other class and that class was just over. So here I am with you guys to solve some amazing problems of circular motion in this amazing problem solving video. So guys, many of you might be new to the channel, many of you might be old to the channel. So just a quick intro about myself. This is my small introduction slide. You can also introduce yourself if you are new to the channel. So I have done my graduation from NIT Nagpur and I did my BTech over there. And after that, I have done my research from IIT Bombay. So here I am because I love physics, I love teaching, and I love seeing that smile when you guys improve and do well in the exams. So you want to be my friend, that's my Instagram handle. And we're going to start with this session. And let me also tell you a very important thing before we begin the class. So there are these free lectures available just for you on the channel. So once you're on the channel, remember you can just go to the playlist tab and if you go just down over here, you will see this class 11th physics nurture playlist. When you open this playlist, you can see all the lectures right from day 1 to day last is available over here, right from units and dimensions. You can see circular motion also has been covered right over here. Okay, so if you want detailed classes, all right, it's all there over here. Just watch it. It's there for free just for all of you. Make sure you make the best use of these classes. And yes, after these classes, these problem solving sessions will help you boost your confidence further. Okay, so I hope you guys have smashed the like button and also hit the subscribe button. Hello Khushi, hello Toshimita, hi Frank, hi Abdul Malik, hi Pawan Kumar, Mudrathi, good evening Avijivan, Nivetha, Kailash, Pawan Kumar, Isaki. Nice to see so many new people. Captain Jack, nice to see you there. Hi Jaws, Mary Legend, nice to see you back over here. Hi Hello Gamer, Satya, hello Kailash. Welcome guys, proud to see all of you. Shall we begin guys? Hello Ganesh. Let me tell you, I was very thrilled and fascinated seeing all the students, your seniors in the last couple of days. We felicitated them. The videos will be out soon. It was so thrilling experience. I cannot express that in words. And I'm so thrilled and also eagerly waiting to celebrate with you guys maybe in a year or two if you are 12th or 11th standard student. So get ready guys. It's not just about celebration, but it's that joy which nobody can express or nobody can tell you. Okay, you have to feel it. And for that, you need to work really, really hard. And I'm pretty sure in the years and months to come, you will be very successful watching these classes for you guys, for which we are taking a lot of effort. And you will become very successful scientists, researchers, doctors, engineers. And I'll be waiting for that day. All right, so let's start with the class. Okay. Quick revision of some concepts before I go to problems. Some problem solving things. Common mistakes which generally people do while solving while solving circular motion problems. See, if I have some kind of a body of certain mass and I know it is going in a circular path of let's say radius r and the velocity is v, then usually when you show the forces and you are drawing the free body diagram and you are trying to find some kind of a relationship, maybe let's say there are forces like this. There is one force F1 this way, maybe there is a force F2 this way, maybe there is a force F3 this way, maybe there is a force F4 this way. These are the forces. Example. Now what you need to do is in these kind of situations, Muthukumar, this is for 2023 batch also. Don't think that this is only for 2024. I think I should get the thumbnail corrected. This is for both 11th and 12th standard students. Okay, so please watch it. It's problem solving sessions. You might have forgotten 11th standard syllabus. Now, when you see a particle going in a circular path, you will immediately understand that yes, there is some kind of acceleration towards the center. That is called as the centripetal acceleration, correct? So this is nothing but your centripetal acceleration, which is an acceleration which is involved only to change the direction, which acts towards the center. It changes the direction. Keep this in mind. This only changes the direction. There is also an acceleration which can change the speed, and that is your tangential acceleration. This will only change, what does it change? Only the speed. So whenever you apply Newton's laws, what you do, be careful guys, because many students make some silly mistakes here. This could be normal mg, spring force, tension, normal, another weight, whatever forces they are. Just solve it like normal Newton's laws. What is normal Newton's laws? Force is mass into acceleration. That's all. It's accelerating this way, right? That's all. So you will say F1 minus F2, force in the direction of acceleration. This is opposite, that's why minus, is equal to nothing but your mass is nothing but your mass into your centripetal acceleration. That's it. And the value of centripetal acceleration, we all know, you can use v square by r, or you can use angular speed square into r. If somebody asks you, what is the centripetal force? Who is the centripetal force in this scenario? Then many people I have seen, they say, sir, mv square by r is the centripetal force. I've held my hand so many times and I've hit my head after listening to such things. mv square by r is centripetal force. mv square by r is not centripetal force. Centripetal force is a name given to a force which propels or accelerates it towards the center. Yeah, the value of that is mv square by r. That is different. Centripetal force is not mv square by r. Understand that. Meaning, over here, these two forces are causing this acceleration. So this is actually your centripetal force. This is your centripetal force. Is that clear? Thank you, NEET aspirant. Thank you. Hello, JEE 2024. Hello, Nikita. Good evening. Welcome aboard, guys. Hello, Ameda Kishori. Welcome. Next important thing which you should know in the tangential direction, very similar. Force is mass into acceleration. It's accelerating this way. So I will just say this bigger force minus the opposing force. Why minus? Because it's opposite to acceleration. Will be equal to mass into tangential acceleration. Tangential acceleration, this is going to change the speed. This is rate of change of speed, dv by dt. Rate of change of speed. Rate of change of your speed. Now if I ask you what is the tangential force, do not say it is F4 or F3. The tangential force is exactly this one. This is your tangential force. Is that clear, my dear students? Everybody? Very good, Captain Jack, Ground Law, Mohan Raj, Joyce, Mary, Nikarika, Sanjit. Hello, everyone. Good evening, Harshad. Yeah. Yes, this lecture will be not enough. Sorry, NEET aspirant, this will not be enough. This will be helping you with problems if you're clear with the basics. If you're not clear with the basics and you want to see some additional theory, please go through my nurture playlist, freely available. I just showed it to you. Okay, great. Now, the resultant of these two accelerations is your total acceleration, A. The total acceleration A. So strictly speaking, this A is the vector sum of centripetal plus tangential, but magnitude wise, it is just AC square plus AT square because they are just perpendicular to each other. So that's the value of your A. And that's all. Okay. So these are some very important things which you should know. Also, in circular motion, I usually prefer comparing the linear terms and the circular motion terms together, which helps you in many ways. Like in linear motion, you have let's say position, then you have change in the position, which is displacement, then you have velocity, which is displacement by time, then you have acceleration, which is change in velocity divided by the time interval. Okay, same things you have in circular motion also. Observe, here you have angular position, here change in the angular position is called angular displacement. Here you have, instead of velocity, angular velocity, which is angular displacement divided by the time. And same thing over here, angular acceleration, which is how much did my angular velocity change upon the time interval. Very, very similar terms. And guess what? These two are also related to each other. Yes, they are related to each other in circular motion. So, say for example, you have this circular motion, this is velocity, this is your acceleration, tangential, this is tangential velocity, this is your radius. So, all these things are related. How they are related? Well, it's simple, guys. I'll tell you how. This V is nothing but, this V is nothing but omega into r. Velocity is nothing but angular velocity into r, and this tangential acceleration is nothing but alpha into the radius. This is how they are related to this omega or this alpha. Even this displacement, and this is also related, this S is nothing but angular displacement into r. This is like the length of the arc. This is like the length of the arc is angle into radius. Do you see that? The length of the arc is angle into radius for small angles. Is that clear? So this is how things are related. You will never forget while solving problems. These are all important things which you should know so that you do not get confused and you remember things in the right way in the exam. Cool? Okay. Okay. Yes, there are both kinds of questions, JEE 2024. Yes, definitely. All right. Chalo. So having said this, let's move on now to some important things which you should remember as results. First is for conical pendulum. For conical pendulum, what and all things you should know. When you take a mass and you revolve it like this, okay, like this, okay. So the tension in that string is given by m omega square into length. L is the length of the string. Also, the string will make certain angle over here. That angle depends on how fast you are rotating it, how fast you are basically trying to rotate it. And the cos of that angle is given by cos of that angle. See, when you rotate it fast, it will make a big angle, okay, it's going to make a big angle. So if omega increases, theta will increase, cos theta will decrease, so it should be downstairs. So omega square L is downstairs and G is on the top. So this is the formula for the angle dependent on the speed. If omega increases, this ratio decreases, cos theta decreases, theta increases. That's how it is. Thank you, Niveta. Thank you, Ganesh. All right. Satya, I will keep posting updates on whenever my next class is on the Telegram channel for sure. I'll be conducting it regularly. Don't worry. Hello, Mr. IITian. Welcome aboard. Hi, Mandalamuldi, Sri Harsha. Welcome. Hello, guys. NEET aspirant, my nurture series is there in the playlist. In the channel only, home, about me, something and all will be there. Go to playlist. Go down 11th standard PCMB classes. In that you will see nurture physics playlist, 11th standard. Okay, cool. Second thing which you should know is for a curved road, the formula. Okay, so whenever you have a curved road and there is a car or a bus or some vehicle which is traveling with certain velocity, then the friction is the one which provides the centripetal force, or else it might get thrown out. So the maximum speed with which it can move, the maximum velocity with which it can move is given by root of mu times radius into gravitational acceleration. This is the maximum speed. After that, the friction won't be able to pull it inside. It's just going to skid outwards. This is the formula for a curved road. Next important formula which you should know is for a banked road. So for a banked road, this is your banking. Banking means you are making the road tilted. Now when your vehicle will go somewhat like this, the maximum speed is slightly higher than this previous case, because you are now taking the help of the road a little bit. So you are not just dependent on the friction, you are dependent on the friction plus the banking of the road, which is the tilting of the road. Now the maximum speed is slightly more. In fact, it is root of mu rg tan. I'm like, what? I thought there was something else. No, yes, it is theta plus alpha. Can somebody remind me and tell me what is alpha? Alpha is not a physical angle over here which is seen. Alpha is basically your angle of repose, where tan of alpha is mu. Tan of alpha is mu. Look at that. This is the maximum speed with which the vehicle can move. A lot of people try to remember a complex formula where you have mu rg tan theta plus mu upon 1 minus mu tan theta. I'll tell you what, wherever you have seen that formula, just replace that mu with tan alpha. Replace the mu with tan alpha. Believe me, you will see tan A plus B formula. Tan A plus B formula. Then it becomes so easy to remember. And guess what? This is the God formula. How is this the God formula? Imagine theta is 0. Imagine theta is 0. If theta is 0, then what happens? It will become just tan alpha. It's not banked. Tan alpha is mu. So it will become, oops, sorry guys, I put mu 2 times. I'm so sorry. This was just rg. Sorry, this mu was not there. Rg tan theta plus alpha. So if theta is 0, just tan alpha will be there. Tan alpha is mu. It will just become mu rg. So mu rg is exactly this equation. When the road is flat, there is no angle over there. So when there is angle, it's rg tan theta plus alpha. Else it is just, rg tan theta alpha. That's all. Great. Thank you, Palak. Thank you so much. Hello, Best Boy channel. Any advices for JEE 2023 aspirants? Focus on your 12th syllabus. Try to complete it by November. And November onwards, try to focus on your 11th revision. That's what I would say. Focus on 12th first. Okay. Now, there is also another angle which you should, another speed which you should know. It's called as the optimum speed for which it has been designed. That is similar formula. Over here, there is no alpha. That's it. Rg tan theta. In this case, there is no friction. Friction is 0. There is minimum wear and tear. There is minimum wear and tear for this particular, velocity. It's slightly less. It's the speed at which you are recommended to drive so that you do not use friction and cause wear and tear of the tires. Okay, great. Now, having said this, also you should know this particular scenario where you have a vertical circle. You have a vertical circle and, you have to reach on the top. You have to reach on the top. So, this is your vertical circle. This is your center. Okay. Now, one case is for a string or for a track. A loop kind of a thing. This is for a rod-like pendulum where there is a rod and a mass attached and it has to go around. So for a string or a track where a car has to go like this upside down and come back, okay? Or there is a thread, there is a mass and you have to move that mass completely on the top so that it comes back without losing contact or without, stopping or without becoming slack. So for it to complete the vertical circle, the minimum velocity should be more than or equal to root of 5 rg. And when it reaches on the top, the velocity is not 0. It's still going to be more than or equal to root of rg. The velocity is not 0 for a string or for a track. It should have some velocity which is more than root rg or at least equal to it, so that it is able to complete the vertical circle. But for a rod, believe me, the minimum velocity is not so much. It is slightly less. It is just root 4 rg. And as soon as it reaches on the top, any velocity which is more than 0 works for it. Small velocity like 0.001, it will go because a rod can't become slack. It will not collapse. Take a thread and take a mass over here and hold the thread here. Leave that mass. Tup, it is going to fall. But you take a rod and connect a mass on the top. Leave it. It's not going to come down. The rod will be able to hold it. The rod will be able to hold that mass, but a string will collapse. So that's why you need that speed, so that it is able to complete that vertical circular motion. Yep. Cool. Very good, Sriram. Yes, Mohan Raj. Awesome. Ganesh Aidapu on YouTube, the batch is already started and it's over. Please watch the playlist of Pathfinder. In the playlist, home, about, channel, videos, etc. playlist, go to Pathfinder, 12th physics playlist. If you want to join the Vedantu batch, it's still available. Go to the description box, check out the link for JEE 2024 or NEET 2024. Okay, Ganesh Adipu. Okay. Great. If you understood till here, I think we should go on to some problems. Here it comes. A particle moving in a circular path due to centripetal force having constant magnitude is an example of motion with which one? Full playlist for 2024, Vikash. You have to watch two playlists, Vikash. One is 11th, one is 12th. What is 11th one called? Everybody tell. 11th one is called Nurture. What is 12th one called? Pathfinder. Okay, Vikash K, is that clear? Hello Ashwin, Bacha, welcome aboard. Sir, DC Pandey book use कर ले हम. हाँ बिल्कुल संजीत, DC Pandey book से you can read you can solve the problems. Don't read theory from DC Pandey, read theory from H.C. Verma. That's my recommendation. All right. So Sriram, there might be other teachers. Don't be so focused on like I want this teacher only. Don't worry. All teachers at Vedantu are good. Number one. Number two, if you want my batches or my classes, I'm conducting micro courses which will add value to your regular classes, like H.C. Verma, like problem solving, Irodo, and then derivations. Those classes you will get it. You take those classes, they are free with the subscription. Okay. Option A is it. What about others? Yes, that's not correct. Constant speed and variable velocity. Be careful. Constant speed and velocity, how is this possible, guys? When you go in a track with constant magnitude of the centripetal force. The centripetal force, if it is constant, that means m into AC is constant. That means m into v square by r is basically constant. That means the velocity is constant. So if the speed is constant, my bad, the speed is constant, but direction is changing. But the direction is changing. That means the velocity is definitely not constant, because velocity, my dear friends, it's a vector quantity, and vectors, both things should remain same, only then it is constant. That's why variable velocity and constant speed. Is that clear? Yes, Mohan Raj, that was the correct answer, which is option D, my dear students. Clear? Awesomeness. And guys, if you have not yet smash the like button, please do that right now. And if you are not yet subscribed to the channel, make sure you do that as well. Let's move on to another question coming up on your screen on circular motion. Yes, Ganesh, make sure you can put up your doubts. Yes, definitely. Whatever you have, if it is relevant, I'll definitely try and answer it. Come on, guys, figure this out. What do you think is the answer for this? Come on. Okay. Yes, Pujari Hamati, definitely it will help you, bacha. So let's try to do this. Okay. I think some of you would have already started by drawing the free body diagram and writing the equations. Let's start as well. So let's assume this tension to be T1, or let's say T3. This is T2. Let's say this is T1. Let's start with the free body diagram for the mass C. Okay. For the mass C, let's try to draw the free body diagram. So for C, understand the only force acting on it is basically T1, and it is going in a circle of radius 3r like this with some angular velocity omega. All the particles will cover same angles in the same time. So when these particles will come over here, they will cover the same angle, that means same angular velocity. So can I not say tension 1 is m into acceleration of C, which is m, masses are same, I think, identical particles, omega square, distance from the center is basically 3r. So T1 is equal to m omega square 3r. Okay. Now let's try to draw the free body diagram for particle number B and see what happens. So for B, okay, it is at a distance of 2r from the center. There is a force this way, which is T2. There is also a force this way, which is T1, but it is ending up accelerating here. So T2 minus T1 is m into acceleration of particle B, which is m into omega square into 2r. But I want to find T2. Take T1 on the other side. The value of T1, which I just figured it out, was m omega square 3r. That's what I just got it. So therefore T2 will be 2 plus 3 is 5. So 5m omega square r. 3 plus 2 is 5. Okay, so I found T1, I found T2 also. There is one more thing. Let's try to find T3, only then I can find the ratio of the tensions. So when I draw the free body diagram of particle A is at a distance of r. From this side, the tension is T3. From the other side, the tension is T2, and it is accelerating this way. So again, T3 minus T2 is mass into acceleration of A. Therefore, T3 will be equal to acceleration of A. Acceleration of A will be omega square r. T2, I just got it from here. T2 is 5 times of that. So 5m omega square r. Correct? So when you solve it, what will you get? T3 will be 5 plus 1 is 6. 6m omega square r. So tension between BC, AB and OA. Tension between BC, AB and OA. BC is the third one. So T1 is 2. T2 is 2. T3. Check this out, guys. Check this out. T1 is nothing but, I think it has the number 3 over here. It has the number 3 over here. T2 has the number 5 over there. So it's to 5. And T2 has the number 5. And T3 has the number 6. Do you see that? 3, 5 and 6. So 3 is to 5 is to 6 is the answer. Just check it out. That's the answer, option D. Yes, it is. Perfecto. So these numbers were important. 3, then this 5, rest all quantities are same. You just had to find the ratio. This is 6. Beautiful question. Done. Very good, Sanjay, Tanish, Esaki, Captain Jack, Ashwin, Haipa, Satyar. Awesome, Joyce. Oh no, Joyce Mary, that's not A. No, it's not A. It's option D. Okay. Cool. Let's move on now to the next question. Okay, Jayashri, very good, Anish. Let's try to solve this. A string of certain fixed length is like a conical pendulum. It carries mass m and it is rotating like this, which makes 2 by pi revolutions per second around that axis as shown. Angle theta is given. So find the tension in that particular string. I think I just told you about conical pendulum, and I told you there are 2 specific formulas which you need to remember. Think about it. NEET aspirant, I'm not taking classes for NEET Pro. Other teachers are teaching. So you can join it. 100% guarantee you will love it. If you don't like it, it's okay. You message me on Captain_Shreyas. Sir, I'm not enjoying the classes. I will try to do something for you. Okay? 100% you will enjoy the classes. Okay? Cool. In the NEET Pro, you will see micro courses. Those micro courses are not shown on the web page. It will be shown to you once you are in the Pro subscription. Sir, I'm taking 3 hours for understanding and making notes for 1 lecture in AI Live. How to speed up? That's okay, Hi-Pi. That's okay. Don't hurry the process. I know it might become a little bit slow. You might not be able to catch up with the live classes. Try to make a timetable. Try to push yourself. Try to find some time. Try to minimize unnecessary activities. Try to sleep less. Push yourself a little bit hard. Even if you get 1 to 2 hours extra per day, I think you can make it. And number 2, don't try to solve everything. Don't try to not understand, I would say. Don't try to do very difficult questions. Even if you're doing basic level 1 questions also, that's okay till the time you complete the syllabus. After completing syllabus, you can level up. Is that fine, Hi-Pi? Okay. Pubit Sri, I always understand what you guys need. That's why I always come up with these sessions. So for this problem, the tension in that string, I told you direct formula is m omega square L, the length of the string. The angular velocity is here, but be careful, this is revolution per second. You need to convert it. 2 by pi revolutions per second is 2 by pi. 1 revolution is 2 pi radians and by second. So pi cancels, this will become 4 radians per second. So use that 4 over here, 4 square, and rest is just L. 4 square is 16. So 16 ml is the tension. That's it. There you go. 16 ml, that's option A. How many of you said A? Very good, Mohan Raj. Awesome. Great. Let me see, guys. All right. Very good. Very good. JEE 2024. Yes, H.C. Verma is good. Yes, very good book. From that book only, students have got all India rank 10, 12, 14. These are my students. H.C. Verma, previous year questions, class material, that's it. Class assignments, notes, whatever class coaching class gives you, more than sufficient for physics. Moving on to the next one. A stone is attached to one end of a string and rotated in a vertical circle. If the string breaks at certain position of maximum tension, where do you think it will break? Where do you think is the highest chance that it will break? Think carefully. So if this is the velocity like this, imagine, okay, think about it. Draw the free body diagrams, you will understand it easily, okay? So I think the tension over here will be like this. Tension at A, this will be mg, this will be tension at B, this will be mg like this, this will be tension at C as well as mg like this. Great. If you look at the accelerations, my dear warriors, accelerating always towards the center, accelerating always towards the center, accelerating always towards the center. So if you start writing the equations for A, for B and for C, it will be very clear now. So for A point, look at it, acceleration is up. So this tension minus mg. So tension at point A minus mg will be nothing but mass into acceleration. Acceleration is nothing but v square by r. So tension at A will be mg plus mv square by r. This is what the tension at point A will be. If you look at point B, in the direction of acceleration, there is only one tension, that's tension B, one force actually, tension B is equal to m into acceleration at point B. So tension B will be m into v square by r, that's it. Now if you look at point C, guys, what will happen? Tension C plus mg, both are downwards in the direction of acceleration, will be mass into acceleration at point C. This was acceleration at point A actually. Okay, so this tension will become m into v square by r minus mg. Now look at all these three, you will immediately understand which out of these three are maximum or minimum. Isn't it obvious? This is the max value and this is the minimum value. In fact, this tension at point B will also be the tension at particular point D also. B and D, it's the same thing, just on the other side. So this is minimum, that is maximum. So if it has to break, where will it break? Obviously at the maximum tension, that is the lowermost point. So option A is correct. If it has to become slack, if it has to collapse, the most probable point is where the tension is minimum, then the answer will be C. At the highest point, highest chance of collapsing or losing the tension, losing contact. But if it has to break, then it is the lowest point where the tension will be maximum. Clear? Purely mathematical, I can prove it. Let's do another question. There is a body initially at rest, starts sliding down like this and goes on a track, like a Hot Wheels. You might have all seen those advertisements, or maybe somebody making a track or a contraption or some video. You leave, or a roller coaster. You leave from the top, it goes down like this and goes up without losing contact and comes down like this. So exactly that question, how high should that initial point be, so that when it comes down, it is able to complete the track without losing any contact? A and C are just opposite. Yes, it is. Sir, if I focus on physics JEE main level problem, will I be able to score good marks in physics? Oh, definitely, NEET aspirant. In fact, there was a student of mine. I just met her in the felicitation function. So she was telling me that she attended all my Irodo problem solving courses and even the problem solving courses of JEE NEET both, and also derivation courses. They were higher than NEET level, 100%. But she, I think, got more than 170, 175 marks, around somewhere that. So out of 180, she scored 170, 175 marks. So definitely it will help you. It cannot do damage 100%. It will definitely, most likely it will give you full marks or close to that. हाँ, HC वर्मा से theory पढ़ना है संजीत मंडल, definitely. Tatva books is enough for JEE mains. Yes, Likit. Konkala. Yes, yes. Mohan Raj saying 5D/4. Let's try to do this. One thing is clear, once it reaches at the bottommost point, for it to complete the track, it should have a minimum speed of root of 5 gr. So from here to here, what has happened is the potential energy got converted into kinetic energy. So the potential energy got converted into kinetic energy. So mgh is equal to half mv square, mm cancels. So gh is equal to half, velocity is root of 5gr whole square. So it will become gh is equal to 5gr by 2, gg cancels. So h is equal to 5r by 2. But wait a minute, I don't want the answer in radius. I want it in terms of diameter. Radius is diameter by 2. So therefore it is 5d by 4 is the value of h. There you go. Hello, Focus on Dreams. Welcome aboard. 5d/4, that's option D. Done, done, are done. Is that clear, my dear students? Very good. Excellent. Moving on to the next one coming up on your screen. The motor of an engine is rotating about its axis with an angular velocity of 100 revolutions per minute. Great. It comes to rest in 15 seconds after being turned off. Assuming constant deceleration, how many revolutions is made before it comes to rest? Yes, Sanjit, HC Verma 11th plus test is volume 1 and volume 2 together. It's 11th and 12th portion complete. Yes, bilkul. Yes, studying rotation is very interesting. Hi Sayantika, welcome aboard guys. Welcome. All the new warriors, I can see so many new names. Make sure you have hit the like and subscribe button and stay tuned and keep watching the videos out here till the end for JEE and NEET. Here it is. Beautiful question on kinematic equations. Remember, sometime back I was telling you, just like in linear motion, velocity is similar to angular velocity, acceleration is similar to angular acceleration, displacement is similar to angular displacement. Kinematics are also applicable. V is u plus at, S is ut plus half at square. You can use it here also. Who is stopping you? So let's try to see what is given. Okay. The motor of an engine is rotating with this much revolutions per minute. So initial angular velocity 100 revolutions per minute, which is 100. One revolution is 2 pi radians. 1 minute is 60 seconds. So 60, this 0 goes. So this goes 3 times, this goes 5 times. So this will become 10 pi by 3 radians per second is the initial angular velocity. It is coming to rest. So final angular velocity 0. Time 15 seconds. Question is, what is the number of revolutions? That means I need to find the angular displacement. Try to think of it in terms of kinematics now. Just think in terms of kinematics, you will get the answer. Come on, come on, come on, come on. Guys, think about it. What should be the answer? We will see. Easy question. Answer is A. All right. So just use your kinematic equations. I think you will need acceleration first. Acceleration is final minus initial by time. Final is 0. Initial is 10 pi by 3. By time is 15. So 10 pi by 3 into 15. If you divide by Yeah, divide by 5, this is 2, divide by 5, this is 3. So this is 2 pi, this is minus sign, minus 2 pi by 9 is alpha. Alpha is angular acceleration. Alpha is angular acceleration. Once I get that, to find the number of revolutions, use final angular velocity square is initial angular velocity square plus 2 alpha into delta theta. Third kinematic equation. V square is u square plus 2as. This is 0. Initial is how much? 10 pi by 3. So 10 pi by 3 whole square plus 2 into minus, because it is retarding, so minus 2 pi by 9 into delta theta. Bring these people over here. 2 2s are 4. Pi by 9 is equal to 10 square 100 into pi square by 9. And this delta theta is also over here. Okay, so pi gone, 9 gone. So delta theta will be 100 by 4, which is 25, and 1 pi is remaining, so radians. Convert it into revolutions, so 25 pi divided by 2 pi revolution, because 1 revolution is 2 pi radians. So 25 pi by 2 pi, which is 12.5 revolutions. Whenever you want to convert revolutions to radians, multiply, radians to revolutions divide by 2 pi. Very good, Saranya. Awesome. Can we keep angular velocity in revolutions per second? Yes, you can do that. Then your units of alpha, everything has to be revolutions per second. Everything revolutions. Revolutions per second square. Like that it should be. You can keep it. Yes. Yes, Mohan Raj. Great. What is this now? A point on the rim of a flywheel. Flywheel is just nothing but a disc. Rim means the end, the circumference. It has a peripheral speed, that means the tangential velocity. The tangential velocity is 10. At some instant, the speed is reducing at 60. Oh, the speed is reducing. The magnitude of the total acceleration is 100. What is the radius of the flywheel? Great. Thank you, Pubasri. Welcome. I'm so happy that you're able to solve. Whole point is building confidence, and believe me, once the exam approaches, then we'll start with little bit bigger syllabus, mock questions and practice, tricky questions. Then we'll also have mock tests, full syllabus tests. All these things are going to happen. So right now we are doing chapter wise approach, then unit wise, and then mock tests, and all these things are going to happen. Okay, let's try to do this. Let's try to visualize the diagram first. So this is your flywheel. There is a point over here. It has some velocity. How much is it? 10 meters per second. Okay. The question is to find the radius. Interesting. I do not know the radius, but it is clearly mentioned that the velocity is reducing at some rate. You know what this means? If the speed is reducing, that means it is a non-uniform circular motion. And in non-uniform circular motion, there is tangential acceleration. Here, since the speed is reducing, the tangential acceleration will be opposite like this, and this is basically 60 meters per second square. Apart from that, because of the velocity, there will be also centripetal acceleration. The combined result of both of them, the combined acceleration of both of them is given to be, the total acceleration is given to be 100 meters per second square. As per the question, that's all. Thank you, JEE 2024. Is that clear? Everybody? A lot of people do not understand why this acceleration is given, why this acceleration is given, and how do we find the radius. This diagram is very crucial because centripetal and tangential are not in the same direction, they are perpendicular. The resultant is this total which is given to you. Okay, now what? Acha, I know one thing. My total acceleration is nothing but, or square is nothing but, centripetal square plus tangential square. So basically the total acceleration is what? 100. So 100 square is nothing but AC. AC I do not know. So AC square plus tangential is 60 square. So AC square will be 100 square minus 60 square. Guys, that is nothing but 80 square. So AC will be 80 meters per second square. Wow. Now what do? I just know one formula to relate centripetal acceleration and radius. and that is centripetal acceleration is nothing but your velocity square divided by r, v square by r. So radius will be nothing but your velocity square by your centripetal acceleration. Just substitute the values, you are going to get it. So radius will be v is 10, so 10 square divided by centripetal, which is nothing but 80. So that is nothing but 100 by 80. 0 0 cancels, so that will become 5 by 4, which is 1.25 meters. See if this is clear. 1.25 meters, yes it is. JEE 2024, as I teach you, no, so every day in the morning I will record it. Okay, so at least some 3-4 weeks or 5 weeks in advance, I generally try to record your classes which you are getting in AI Live. Okay, so that's how it goes. Again A. All right, cool. Uday, you missed a lot of amazing questions. No problem. Watch the remaining part. You can watch the missed part later on. Okay, a beautiful question coming up again on your screen, and here it is. A pendulum bob is having a length of 0.2 meters, describes an arc of circle in a vertical plane. If the tension in the cord, interesting, is √3 times the weight of the bob, when the cord makes 30 degrees with the vertical, then the acceleration of the bob in that particular position is. Hi Khaja Dhunlu. Hello Suji Venkatesh. Again A. Yes. Chalo, let's try to see how to solve. Okay, let's draw the diagram. So this is my pendulum, this is my hinge point, this is your mass over here. Okay, it is going to make certain angle with the vertical. So let me just draw the vertical line. This is 30 degrees as per the given question. Also it's given that there is tension in the string, and that tension value is √3 times the weight of the bob. Okay, we'll substitute that later. Mg will act downwards. Mg will act downwards. Mg will act downwards, but clearly you don't have to write Mg. Split Mg's components because this is 30 degrees. So there will be two components. I will need to split it. Without that I can't solve. So this will be Mg's cos 30 component, and this one will be Mg sin 30 because it is away from it. The angle which is closer, 30 degrees, is adjacent, so cos. Sin is always opposite, or the one which is away from the angle, so this is sin component. I think that completes your free body diagram. And now at the same time you also show the accelerations, because the question is the acceleration of the bob is how much. That's the question. So clearly there will be one centripetal acceleration, there will be also one tangential acceleration, and the result of both of them together is nothing but your total acceleration. In the question, what has been asked? In this questions, what has been asked? Think the total acceleration. Captain Jack, these are conceptual questions. Don't think about the length, the time. I'm explaining to you, that's why I'm taking time. Believe me, if I have to solve this, I will solve it within less than 1 minute, okay, or maximum 1.5 minutes. So in the exam also, when you get these questions, you will be solving maybe in 1.5, max to max 2 minutes, not more than that. When I explain, there are so many things involved which goes on in your mind in the background, which has to run, okay? Your thinking processors are all lighting up. You will think fast, but when I explain, I have to make you think that. I have to make you understand things. So that's why I will go very slow. Okay, cool. You have to find acceleration of the bob, that means A. Okay, do I know 80? I think I know 80. How? In this direction, along the tangent. Along the tangent, here is what I can say. The tangential force is mg sin 30 is equal to mass into tangential acceleration. So therefore, tangential acceleration, m cancels. Can you see that? M and m just got cancelled. So tangential acceleration will be g sin 30, which is g by 2, because sin 30 is half. Great. Now along the string, what is the equation? You can say tension is in the direction of acceleration. Mg cos is opposite. So tension will be the bigger force minus the opposing force, which is mg cos of 30 will be mass into centripetal acceleration. But it's given tension is √3 times the weight. So tension is √3 times mg minus mg cos 30 is √3 by 2. Centripetal acceleration I need to find. M again just gets cancelled everywhere. Observe √3g minus √3g by 2. √3 minus √3 by 2. 1 minus half is half. √3 minus √3 by 2 is √3 by 2. So this will be √3 by 2 g is equal to centripetal. Obviously, now the time has come to find the total acceleration. Total acceleration will be root of AC square plus AT square. So it will be root of √3 by 2 g square plus g by 2 square. So this will become g is common. Under the root I have 3 by 4 and here I have 1 by 2 square which is 1 by 4 which is g root of 3 plus 1 is 4. So 4 by 4 which is 1. So it is g. Check this out. Is it option A? Oh my god, again option A. Yes, answer is A. Yep, it is. Vanakkam Loheshwar, Mahi Balnan. Thank you for calling me Thala. I'm so glad. Alright, so there you go. A lot of people usually end up calculating this and mark it as g by 2. They completely forget that there was centripetal. Some people calculate centripetal and they write the answer as C. Okay, but those are the smart ones who calculate centripetal and tangential and combine them together to find the total acceleration. That's the catch of this question. Okay, let's see what do we have over here. A beautiful question coming up on your screen. So I think we should ask Loheshwar only, because that's, I think, a term generally used in Tamil. Yes. Sorry. Yes, sir. You got it at C. I knew it. Many people will make that mistake purposely. So two particles A and B move in a circle of radius of this much anti-clockwise with speed 1 and 2.5. The initial positions are given. The time after which, how many times do A and B meet each other before they meet at C? What a question. What a question. Hello Jagandeva. Beautiful question. How many times do they meet? A and B will meet together. Maybe they will meet here. Okay, maybe they'll meet here. Then again they will meet maybe somewhere here. Maybe again they will meet somewhere here. So question is basically, how many times do they meet before they actually meet at that particular point C? Interesting. Let's try to do this. First of all, okay, A and B are separate by some angle which is 90 degrees. Maybe they meet together at the first instant over here. Let's say the angle covered by A, I call it as theta 1, and B will have to cover a slightly higher angle. Let's say I call it theta 2. Theta 1 is the angle covered by A before they meet, and B is the angle covered by B before they meet together. A and B meet together over here. So here at this point, they meet at the first time. Now, I think you can also see what is the relation between theta 1 and theta 2. If you observe carefully, theta 1 plus pi by 2 radians, theta 1 plus 90 degrees is that complete angle theta 2. Do you see that? How many of you saw that? Everybody? Thala means captain in Tamil. Oh, yes. Oh, okay. Thala means I was thinking of Thalapati Vijay like something out of respect, generally given to the movie stars or somebody, politician or some great personality. Okay, fine. Now I got to know the real meaning. Leader. Oh, yes. Something like leader. Yes. All right. Hello, Alvin. Nice to see you back. Long time. A little bit late, I guess. Okay. Now, theta 1 is pi by 2 plus theta 2. Okay. Now, angle covered, remember, angular displacement is angular speed multiplied by the time taken to cover it. Okay, so can I not say theta 1 is angular speed? Oh, what is the angular speed of object A? I think we can find that out. Omega of A is V by R, V of A by R. V is omega, so omega is V by R. Velocity is 1, radius is 1 by pi, so it is pi radians per second for A. Angular velocity of B, again velocity is 2.5 divided by radius, which is 1.1 by pi. So 2.5 is 5 by 2 and this is pi, so radians per second. So if I substitute it over here, let's see what do I get. For the first one, it is pi into t plus pi by 2, okay? And over here for theta 2, that means the angle covered by B will be 5 pi by t, 2 into t. Okay, so check this out. Over here, what is the value of t from this equation? Shift that over there and you will get it, I think. So 5 pi by 2 minus pi, the whole thing into t, is equal to pi by 2. 5 by 2 minus 1 is 3 by 2. So 3 by 2 pi into t is equal to pi by 2. 2 cancels, pi cancels. So t is equal to 1/3 second. T is equal to 1/3 second. Okay, great. Now if time is 1/3 second, how much angle did they cover? We can find that out very easily. Theta 1. So theta 1 will be pi t. Theta 1 is just pi t. So pi is nothing but, time is nothing but 1/3, which is basically 60 degrees. So they met for the first time at 60 degrees. I think after this also again they will meet. Yes or no, guys? After this meeting, for the first time, they will meet again after some more time. How much more time will they take? Well, that you can think easily. If they meet again for the second time over here, let's say this angle is theta, starting from here. Think this way, okay? If the first particle completes some angle, this is for the second case, from here to here. The first particle completes an angle, okay? Maybe it has moved by, let's say, some angle over here. The other particle would have covered, not just that angle, but also extra 2 pi radians. So the first particle covers theta 1, okay? The other particle will cover theta basically. The other particle will cover theta plus 2 pi. So the slower particle has moved only theta. The other particle will go like this and meet over here. So theta plus 2 pi is the angle covered by the second particle. Second particle displacement will be 5 pi by 2 into new time. This one over here will be pi into t plus 2 pi. Just solve this now. 2 pi will be equal to 5 pi by 2 minus 5 pi by 2 minus pi, the whole thing into t. This will be 3 pi by 2 into t. This is 2 pi. So pi cancels. From this you will get the value of time as pi goes 4 by 3 seconds. 4 by 3 seconds. Just check this out. Pi goes 4 by 3. From this theta, you will get it as pi into the time 4 by 3. Clearly, this is more than, theta is more than 180 degrees. What it means is that second time they do not meet over here or before this, they meet quite after this. That means before they come over here, they only meet exactly once. That is over here at 60 degrees. A and B, they come and meet over here. By the time they meet again, this meeting point is not here, maybe it is somewhere here. That's what it is telling you. It's completely weird and different problem. Yes, it is. But I think it was important for me to discuss because these kind of concepts have come in JEE Mains many times. Rashmi, I'm very good. Okay. Now, these parts are very critical. Especially, let me highlight these. Which parts are very critical? This equation, if somebody knows how to write it, your job is done. Let me just explain this to you so that it is very clear. For the first time, what I did was, this particle covered theta 1, this particle covered theta 2. So, theta 1 plus 90 is theta 2. Theta 1 plus 90 is theta 2. That's for the first time. For second time, once they both are meeting here, let's say first particle moves this much. The second particle would have moved extra 2 pi radians. First particle moves theta. The second particle will move extra 2 pi radians. So first particle's displacement plus 2 pi is the second particle's displacement. That's all. If you know this, you will get it. Okay, so this was the last question which I had planned for you. It was one of the most difficult questions of today's session. I hope you could bear with me for that. But it was a lot of concepts and definitely very involving, especially if you want to crack and get really awesome marks. Now I have a question for all of you. This is a homework question. Make sure you solve it and drop the answer in the comment section after the session is over. Solution, everything will be given to you in the Telegram channel, which is available to all of you. So guys, these are our classes. Make sure you are a part of it. And let me also tell you, there are doubt solving facilities as well provided to all the students as a separate package. So in case you just want the doubts to be solved, even that package is available. So make the best use of it so that you can beat these top results which we have produced this year and you get really, really amazing marks. All the courses links description box, it's available. Make sure you are a part of this revolution and you join and improve your scores by the time you reach and approach the examinations. I hope you guys have enjoyed these classes. Okay, and make sure you are very regular, and if you have anything to ask me, please put it up in the comments. I will try to help you out. Else, if you want to get in touch with me also, that is possible via WhatsApp or even Instagram, which is captain_Shreyas. So you can get in touch with me over there. मला मराठी एकदम मस्त येतं JEE 2024. झकास स्कोर करूया आता. ठीक है? Okay. Now I'm not in a mood of talking Marathi because now when I'm speaking English, it won't come so fluently. But anyways, all right. So have a great time and yeah, take care. Take care. Okay. Bye. Bye guys. Bye TG Bharat. Bye JEE 24. Bye Jagan. Bye Samuel. Bye Vimula. Thank you guys. Thank you. Welcome. Take care. Take care. Yes. Stay tuned. And Samuel, you need the timetable. Well, if you can watch my previous class of Can I Still Score, and get top 2000 rank in JEE. I have given a brief idea of the timetable, but still if you want a more detailed version, you can get in touch with me on my Instagram. I will try to personalize and help you with the timetable. Okay, bye bye guys, take care, have a great time. Hasta la vista, Captain Shreyas signing off.